what about the nature of it, that one? So let me, there's a block. I'll drop it from a height h1. It will fall here. So here the block will collide, the same block, that one, and it will rebound. It will, the sequence I'm showing it, and it will rebound. So here let it be v1. Then after rebound, let v2 be the speed, and the block will rebound to a height h2. Let me give this information. Let h1 is equal to 20 meter and h2 equal to 10 meter. This is released from rest. A very small information is there, but very important for us. Means during collision, why we neglect few forces, why we should neglect the weight during the collision impact. That's what I'm trying to explain here. Now it will come and collide, and let it be in contact, the contact time. Let me put it 4 microseconds. So let it be in contact for 4 microseconds. So what is delta t? The ball will be in contact with the ground. Okay, what is V1? So let's calculate V1. V1 equal to 2GH1, 2 into 10 into 20. So 20 meter per second. What is V2? 2GH2. So this should be 2 into 10 into 10. Let me make it 5. Calculations will be easier. So this will be 10 meter per second. Then let's define the quotient of restitution. So what is the state of ground? Ground will not move. No? Then applying the quotient of restitution formula, E equal to V2, velocity of the ball, final velocity of the ball, minus final velocity of ground by initial velocity of the ball minus initial velocity of ground. This is the first time I'm showing it, this one. This is the final velocity of the ball. Upward, let me take positive. How much it is? V2. That of the ground, 0. Initial
Sir,
velocity of the ball.
initial velocity of ground, sir.
Yes, sir.
First.
Oh, okay, there's a sign. Huh? Initial velocity of ground minus initial velocity of ball. Initial velocity of the ground will not move. No? So then initial velocity of ball minus V1. So this will become V2 by V1. So hereafter,
Sir, but V2 is not root 2GH2.
Sir, we can't hear you.
all of you, can you hear me?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes
Can you hear me?
Yes, sir.
Sir.
Can you hear me?
Yes, sir.
Some connectivity problem. Okay, let's talk about the any normal contact will act during that collision time. Yes, a normal contact will act, and that normal contact into time. Shall I take that as impulse? Shall I take that impulse here? Because the normal contact will act for small duration time. Can you write? And also the weight will be acting. And what is delta t? The time. The ball will be in contact with the ground for this interval of time. Okay, now let's write the normal contact. Is it n equal to mg? Is what I'm trying to explain here now. So let's write the impulse momentum equation. So what is initial momentum? mv1 minus jy is equal to minus mv2. Why it should be? Because how jy will act opposite to initial momentum mv1. And what about final momentum?
Sir, we can't hear you.
Sir.
We can't hear you, sir.
Can you hear me now?
Yes, sir.
Yes, sir.
Some electric power gone. Oh, we'll see. Okay, we'll manage now. This is jy. So we know mass of the ball 2 kg. So let's substitute here. 2 v1 is how much? 20 jy is equal to 2 into this is 10. So what is value of jy? 40. So 60 Newton second. Now let's come. What is jy? I should write n into delta t. 60 Newton. So what is delta t? 4 microsecond. 60 by 4 into 10 to the power of minus 6. 15 into 10 to the power of 6 Newton. Look at the magnitude. And what is the weight mg? How much it is? Just 20 Newton, no? But the normal contact that is acting, how much it is? 15 into 10 to the power of 6 Newton. It's a very much greater than the weight, no? So weight will also set up impulse. Yes, there'll be impulse due to weight, but the impulse set up by normal contact is far greater than the impulse set up by the weight. So therefore, in all our collisions, shall we consider the effect of weight during collision? Negligible. So here what we can say, impulse due to weight, mg into delta t, negligible. Compared to what? Compared to impulse set up due to normal contact forces. Is that okay? Now, sir, sir, how come that such a large force will act? As the body will undergo deformation here. Due to that deformation, the molecules will exert a force. It's all. I think at molecular level, we can't go for it. The body will be in contact. When it is contact only, all together, the average normal contact that is acting is equal to this much here. And what happens? That normal contact will first the moment it comes initially zero, no, before striking. So as it starts striking, as it comes in contact with the ground, it starts increasing, becomes maximum, then decreases. The sequence, everything will take place. And what we are calculating is, this is like some sort of the average. So therefore, what you can do is, definitely when you talk about impulse, no, you should be very careful about the normal contact and any other forces acting. Will they set up impulse or not? You have to be careful. Okay, no. So this is the some general idea. So let's take some related to vertical collision only. Few more problems will take. Then I'll go for the basic impulse one.